All right, so another thing I'd like you to know is the difference between enantiomers. So enantiomers are a type of stereoisomer. So they have the same bonding but different spatial arrangement. And remember, enantiomers are non-superimposable. Mirror images of one another. And so example of that is your hands. Right, if you take a look at your hands, they're both, you both have a palm on each one, 4 fingers and a thumb, but they're not the same, right? You can tell the difference between your left hand and your right hand. And if you kind of point them palm facing towards each other, you can see they're actually mirror images of one another. So in order to have an enantiomer in a carbon compound, you need a carbon with 4 different groups. So let's take a look at a carbon with 4 different groups. So we'll have a hydrogen, a chlorine, a bromine coming out of the board, and then an iodide going into the board. And then we'll draw a little mirror, and then we'll draw the mirror image of this. So again, we'll have this carbon, hydrogen. This time the chlorine will be to the right. The bromine will still be coming out of the board. And the iodide will still be going back into the board. And so one question I'd like you to be able to answer is I'll draw you different kind of rotations of this, and I want you to know, are these enantiomers or are they the same molecule? So let's see what happens when we rotate about this bond. And we'll draw the rotated version here. So we're going to rotate it so that our chlorine is faced in the same direction, right? Our chlorine is here, our chlorine is here. And so we've rotated 180 degrees to do that. And then if you think about what's going to happen to the iodide when you rotate 180 degrees, instead of going back into the board, it's going to be coming out of the board. And then you think about the bromine, when you rotate that 180 degrees, instead of going out of the board, it's going to go back into the board. And so if you compare this structure with this upper structure, you'll see the bromine and the iodide are in different positions. And so they are non-superimposable mirror images. And so they are not the same molecule. They are enantiomers of one another. And so this is very important for kind of drug design. A lot of drugs are stereoselective, that they can only one-handedness of the drug will work. So right hand drug might work while the left hand might not. And so this is an example down here. You've got kind of the receptor, the binding site of the receptor, and you can see they've made a little triangle, square, and circle, and you can see it's got a specific kind of arrangement that needs to fit. And so when you have this kind of enantiomer, it works out well, and you can send that signal, but you can see here, this does not fit, and so this would not work. So only one enantiomer would actually cause some kind of cascade and chain. So know the difference, or be able to tell whether 2 molecules are enantiomers of one another, or if they're the same molecule.